Hello everybody and welcome back to the channel. You see a couple of things on my desk here today, but this video is really about the RYLR993 LoRa node setup, and it's about this little chip called the Reyax RYLR993, and that's it, and that's its antenna. And what this guy does, it sends, it uses a simple AT command set to send data or sensor data over the LoraWAN network to a LoraWAN gateway. And the gateway I have is a SenseCap M2 that runs ChirpStack. So and I have another video where I configure that M2 gateway. Take a look at that video, and that will tell you, you know, how to do that. So let's have a look at the computer over here. So this video, I will be using a ESP32C3 Super Mini. That is the just a very simple ESP32 chip, or that I can use to generate sensor data, so that we can see the data inside of ChirpStack on the M2. And but of course you can connect to that ESP32C3. You can connect real sensors if you wanted to. Otherwise, you know, and you can send a lot of data from any type of sensor. There are thousands of sensors that you can send data from. And the ESP32C3 gives you the opportunity to read that data in a very proprietary manner and then send it using this RYLR993 to the LoraWAN gateway. So you can connect almost any you know, sensor on the other side of the ESP32. I'm using US915 ChirpStack, and I'll activate over-the-air activation. So first of all, connecting this thing, you will see, and there it is, you will see that I've got 3.3 volts connected. And note that I said 3.3 volts, not 5 volts, so 3.3. And then I've got a bridge from 3.3 into this NRST pin. That has to be pulled high for this thing to work. So that's one of the lessons I learned, is pull that high with just a bridge, 3.3, but again 3.3. Then I got send and receive, and then I got ground. Okay, so that's really how it's connected. So very simple. Now you can also just connect this directly to your PC. It's best to get one of these, which is a let's see, this way around, RYLS135. Now this thing can pull up to an amp of power. It can provide, so the chip's not going to reboot when you got this connected to your PC, and it will work perfectly. So there's a lesson learned right there. So if you want to program this from your PC, get a decent you know, USB UART like this one. Okay, so remember the 3.3 part, not 5 volt. Okay, so if you want to see if this chip's alive, you would connect it exactly the same. You know, you would connect, and you'll see on this side the ground and the 3.3 volts. Again, 3.3, not 5. And the TX and RX, you would connect that to your USB UART, and you can, you know, if you want to see if it's alive, you can just use a terminal putty or something like that, and you can issue a AT command, and you should see a OK. And if you see that, you know that your wires are correct and the chip's alive. Okay. You can look up, it's 9600 board. You can look up your dev EUI. Mine came set to 0000, but you must have a proper DEUI set. So before, because every chip has to have its own unique ID. So one of the things I had to do manually, I connected it to my PC, and I learned that it has to be an 80 plus op mode equals 0, and not op mode equals 1. It has to be in LoraWAN mode. So you've got to set it to 0, not to 1. And then you issue an ATZ command, and that reboots the chip, and it should come back, and everything's cool. So now your DEUI, you can generate one using Python, or if you look inside ChirpStack, and this is my ChirpStack, and again I have a video on how to set this up, the SenseCap M2 with ChirpStack inside. If you go look at your application and I add a device, one of the first things of course you have to do is you have to create a device profile. And I'll go show you in a second how that looks. Then you can generate a EUID UI. You can generate one here, or you can generate one using your just a little Python application or function. So I'm just going to create one over here. So I generated a key, so I can take this key and I can write it down. And then application key, I can generate one in here again, and this is the other key that I need. I need this application key, and I got to write that down. So that's my OTAA keys. That's the key that it would need to activate over the air. So so those are the two important things there. So you can issue those commands if you've got it connected to your PC. You can then issue this, and you see the colons in between there. So AT plus DEUI equals, and then that key that you generated, or that ChirpStack generated for you. And then you got to put your app key in here. That's again the one that was generated there. It's important to set this NWK key EY to the same value, set it to the same value. And then I'm left all the app EUIs, I left them all blank, all zeros. Okay, that took a while. It wasted 4 hours of time to get that working, but that's important. So I'm in the description below, I'll add a little Arduino application. So you can actually go set these values inside the Arduino application. Again, you can set that DEUI, which you got, you can set all that to 0, and the app key, you can set those inside of the application. So in that case, you're gonna just run the little application. So you enter these values into the Arduino application. You're not going to use the USB UART to program it. You're just going to use the application. So what the application does is when it boots up, it automatically sets it to LoraWAN mode, it sets it to that ATOP0, and it does a reboot. Then it sets all the keys, and it sets the max power and ADR on, and then it's going to start sending a join command to join the network. So if everything works out, you'll see some LEDs flash, and then it's going to start sending a temperature, humidity, and a battery value every 30 seconds. So what you'll then do is you'll, again, I use Platform IO, but you can use the Arduino application itself to flash that onto the ESP32C3. So make sure that your COM ports are clear. If you're using a platform I/O, make sure that you have your board set to this ESP32-C3-DevKit M-1, and make sure everything's closed. And then since I did this on a Windows machine, I just ran platform I/O run upload to COM18, and it flashed it for me. But again, you can do that from within Arduino as well. So once it's flashed with all those values, everything's good, and then it tries to join. If you're having trouble, again in ChirpStack, you can go into the application. So I'm just going to go into application over here, and I'm going to go in here, and I'm going to go into OTAA keys, and I'm going to flush the 08 of the keys, and that helps to clear out all your retries, and it starts again. And so that's one thing I learned. Just clear out ChirpStack and see if it wants to join that if you're having some problems. So then once the application starts up, it gives you these little sequences. There's a quick flash, then there's a 2-second solid flash, then there's a long blink, and what that means is the ESP is alive, okay? It was able to get a AT, and it got an OK. Then it's going to do some AT tests and, you know, set that to LoraWAN mode. Then it's going to set all the configuration values. Then it's going to try and join, and then it's going to do this long 3-second solid, and that means it's joined. So let's actually do that. I'm going to hold these two chips here, and I'm going to and again over here you'll see the pinouts. It's fairly simple. I'll put a document as well that shows these pins, but these are currently connected to 20 and 21, TX and RX, and then the 3.3 and ground. And the other side I've shown you. So we can see that there was the quick flash. That means it's alive. Then there's a 2-second solid that the chip is starting up. We can see that the RYLR is flashing red, meaning it hasn't done anything. There we saw it flash a few times, and there comes the 3 little flashes. Or that's actually the 2-second. Now there's the longer wait time. We can see that the blue light flashes on the RYLR chip. That means it's joined. And if everything's good, at this point it's going to try and start sending data. So we will see that this turns into solid, meaning it's joined, and we can see that the green light flashes on the RYLR, meaning it transmitted some data. So that's really all that happens there. Those are the LED cycles, or whatever you want to call them. Well, let me show you in ChirpStack then what it looks like. So if I go into the application, and I am going to look at this, and I'm going to go look at device matrix, and I'm going to make it the last 24 hours. We can see that values are now coming through. So if we look at the events, we can see I started it up now. There was a join, and then there was a status, and then it's starting to send the data. So if we look at the actual frames, we can see there was a join request, then join accepted, then it's starting to send the data down. Okay, so if I look at this data, there's all the data. If I go look at the actual events, I can see inside the events, I can see there's the temperature, the humidity, and the battery level that it's sending. Okay, so those are the values. So we know it's working. Now, one thing that's important here is this is, I said in the beginning, you have to have a device profile. So the way I set up my device profile, and again, that's if you go look at the application and you look at this, I'm trying to create a new one here, but if I go into configuration, I chose a device profile here. So that's the other very important part, is to, I'm just going to remove this one for now. What's important here is to set up your device profile. I set this one up. You can see that I'm using 915, so I'm in the US. I'm using LoraWAN 103. You can change that, of course. But then if I go to codec, you can see here is the codec that decodes the values. So you can see temperature in here, humidity and battery. Now this is just a little JavaScript function that decodes the data and turns it into temperature, humidity and battery. So these codecs, and there you can see the actual values. We're looking for battery, humidity 2 and temperature. So how this works is, if you go look at the actual a frame received, so let's go look at an event. This data over here, this piece over here, is what's received via LoraWAN. That's what the chip is sending. And that codec decodes this into values. So if you go look at that, there's the values that it decoded it into. Temperature _1, humidity 22. So it decoded this value and turned that into actual data. So, so that data can then, of course, be plotted onto you know, a graph like this inside ChirpStack. The next level from ChirpStack up is you can go into something like Grafana, and I'll do that in the next video. I'll show where you can start sending that data into a Grafana using MQTT, and then now you can see, you know, we're reading the temperatures, we're reading the humidity. You can start drawing graphs, doing all sorts of things, and you know, build various dashboards, and you know, here's all the sensors. And you can do a lot of stuff. You know, once the data is flowing, you can start drawing a lot of this kind of stuff out. So that's it. You know, it's really simple. The hardest things for me, that the lessons learned from this was it ships with all zeros. Some people say it does have a dev EUI on it, but you can discover that with that. And I had to set that, so I put that into the little application. And then, you know, I set these two values. The NWKKEY, set it the same as the app key. That was a lesson learned. And of course, you want to add it, the device like I showed you, into ChirpStack, and then power it up. Remember that pull up needs to be there. And you can use this Python OS OS_urandom16 to generate a key, or you can have ChirpStack generate your key. So that's it. Basically, after that, it is sending data. I have several of these. I have 2 of them, and they are busy sending data. Like you saw, I can put it into graphs, and I can do all sorts of things. And that data can really be anything at the end of the day. But yeah, so that's basically it. Let's have a look. If this guy wants to do one more round for us, we will see that it waits 30 seconds. And let's see if it actually wants to send some more data. We can see that it's blue solid over there on the ESP32C3. And there we can see a little green flash. That's when it sent the data. The packet just went. And of course, with an antenna like this, you can have an external antenna, and that data can travel many miles through the air. So now these sensors can be really, really remote, sending data to your LoraWAN gateway, which you can then put on graphs and do whatever you want to do. So hopefully that was somewhat educational. If you got any questions, ask. I can try and figure it out. I'm not the super expert at this, but that's what I figured out so far. So thank you for watching, and let me know if I can assist.